And the next topic is cooling of alternator, and we have to provide ventilation for the alternators, particularly because of the losses that has been produced due to heat in your alternator. That is a specific reason. For small machines you can provide fans in your alternator so that it can pull in sufficient amount of air to cool down your machine, but for larger machines you have to handle different methods for cooling. And here we'll study about 5 different methods for cooling, and the first one would be your radial ventilation, second one would be your axial ventilation, third one would be your radial axial ventilation, fourth would be your multiple inlet system of ventilation, and fifth one would be your closed circuit ventilation, or alternatively called as hydrogen cooling. This would be your standard your 10 mark question in your examinations. And in radial ventilation, your air is passed through the radial ducts that are provided, and they are used particularly for small size alternator which are so small in size, and cold air is allowed to flow inside the machine through the ends of the rotor, and is passed through the surface of the rotor and reaches the air gaps particularly through the radial vent ducts. And this is your diagram of your ventilation, radial ventilation. Here the air passes through the air gap and reaches your windings through the radial ducts, and in axial ventilation there are subslots provided below your main slot through which the cold air is passed through, and you have to mention this. And next topic is radial axial ventilation. In radial axial ventilation, we cool the machine through both the methods, that is through axial ventilation and also through radial ventilation. The air enters the chamber through the axial ducts and moves on to other parts of the machine through the radial ducts that are provided. Okay. See, I'll come below, have a look at this picture, you can have a clear idea of radial axial ventilation. See, the air enters through the axial ducts and move on through the radial ducts that are provided. This is the method used for cooling large turbo alternators and large machines where your natural cooling is not sufficient enough to cool down your machine. There is a main aspect here, and the air that passes through your radial ducts move along the air gap and circulates inside the machine to cool it down to the required amount is more important. Your next topic could be multiple inlet ventilation. In your multiple inlet ventilation, what we would be doing is the air is injected through multiple inlets. That is, your alternator is split into 2 parts, in 2 compartments, and each one compartment is for acts as an inlet and other compartment acts as an outlet. There are 2 chambers here, one is inlet chamber and the first one is outlet chamber, and they are alternatively placed here. If one chamber acts as an inlet and the other chamber acts as an outlet. Please have a clear look in this picture here. Here in one chamber the air enters, and in one chamber the air leaves. See the top portion, you can clearly have a picture of it. That's what I am trying to say here. One part acts as an inlet and one part acts as an outlet. And next is closed circuit ventilation. These ventilations are particularly used for large turbo alternators where your conventional cooling methods doesn't work. And here in particular we are using hydrogen as a coolant medium, and this setup is arranged below your basement of your alternator. Okay, here the hydrogen is kept at a pressure higher than that of your air so that it doesn't combine with air and your cooling gets affected. And this is the efficient cooling method that is available till date, and they are provided with a gas tight casing so that your gas doesn't escape. Okay, and the pressure is maintained greater than atmospheric pressure, as I said earlier, to prevent leakage of air into the coolant medium. And the precautions that you have to take is the hydrogen should be of pure form, and you have to provide maintain the pressure higher than air, and it should be properly enclosed, and the advantages also has to be taken care of. These are the precautions that you have to done. That is, hydrogen should be of pure form, proper sealing should be provided, and hydrogen should be maintained at a pressure higher than that of air. Next one is advantages. Here it reduces the losses, that is a main advantage, and efficiency get increased as the losses are reduced, and hydrogen is 1.3 times provides 1.3 times heat transfer rate that of air. Due to low density, the operation is purely noiseless, and there is no chance of fire accident as hydrogen is non-inflammable. It is a major advantage for you here. Okay, thank you.